And welcome everybody to the Daily Space Weather Show. If you're coming for the world's most comprehensive daily space weather content and the most detailed solar imagery you'll find, you've come to the right place. These are 24-hour videos from Solar Dynamics Observatory. It's the house favorite wavelength, 171 angstroms. And let's take a little closer look. We've got about 135 sunspots at the moment. Radio flux now at 169 solar flux units. We do have a couple more sunspots which have recently risen over that eastern limb to your screen left. The most active sunspot would be also on your screen left at the moment. That sunspot still does have the kind of magnetic fields that could be associated with large solar flares, including possible X-class events. We've got some massive filaments setting over the western limb as well. We decided to include that basically just for the aesthetics, giving you a great perspective there of the size of these features with our Earth scale. We do have two large sunspots on the eastern quadrant. That's the larger of the two major sunspot groups over there in the east. It is also less magnetically complex than this sunspot group, which may have a similar amount of overall umbre. I think it actually even has a little bit more. That's probably like 80 sunspots just by itself right there. That sunspot group contains a lot of umbre and a lot of magnetic complexity. And we're going to show you lots more imagery here in a moment. First, there's 131 angstroms as well. And things have been pretty quiet here over the past 24 hours, while a couple coronal mass ejections are headed in our direction. Coronal mass ejections headed in our direction. It's what you like to see when you're covering space weather. We always like to see it. Let's take a look at what's going on Earth. But first, press the like button if you enjoy the content. And let us know what you think of the rebrand. The Smash News Network, least busted name in news. It's the world's most comprehensive daily space weather content and most detailed solar imagery. And let's see what's going on planet Earth. Well, one of the things that's going on is some new spatter cones are forming on the Reykjanes Peninsula of Iceland. So there you go. There are two of those new spatter cones. So at least two there in this hellscape, really. Really a surreal scene there in Iceland with another eruption adjacent to the town of Grindavik. Whatever it's called. Anyway, it looks like a lot of volcanoes are currently erupting. So then there are those spatter cones in the daytime, at least more like half a dozen spatter cones they're forming on that fissure. Subanose-jima is also erupting, 5,000-foot ash plume there. Mount Ibu exploding. Semeru erupting in an explosive fashion as well. Mount Merapi there, still on the list. Dakono. Rupahu has actually calmed down. A little bit of cooling happening there in the crater lake. Some sulfur dioxide outgassing also. Popocatépetl erupting. Santiaguido, Fuego, Sangay, Revenador, and Sabancaya, all in eruptive states. Next, 7-magnitude earthquake drought continues. You see that? No 7-magnitude earthquake droughts for an extended period of time. Keep in mind, folks in an earthquake-prone zone, 7-magnitude earthquake droughts end in large earthquakes. So stop your grinning and drop your linen. Here come the 5 and greater magnitude quakes for the past 24 hours. Pakistan had a 5.5. Suboptimal for Pakistan. Suboptimal. Those buildings are not the optimal buildings for earthquakes. Kermadec Islands had a 5.5 also. That area there north of New Zealand. Besides that, things have been pretty calm. Only 2 5 and greater magnitude quakes for the past 24 hours. And a fairly low number of quakes as well. And of course, before we show you more space weather stats, let's show some more SDO imagery, shall we? Hey, oh my god, it's the Smash News Network, least busted name in news. There's 304 angstroms wavelength from SDO. And let's instead switch to some stats. 10.7 centimeter radio flux, 169 solar flux units is the 10.7, otherwise known as the F107. It is a proportional data set to sunspot number. As you can see there, the red line and the black line are highly proportional, directly proportional. In other words, when you see a high sunspot number, you see a high radio flux, and you can expect it to keep creeping up for about another 7 months. Expecting solar maximum sometime around October of 2024. So, here's Space Weather Enthusiast Dashboard, and like we said yesterday, NOAA agrees with our forecast from St. Patrick's Day. So, indeed, there is some activity headed this way, expecting a geomagnetic storm tomorrow night into Thursday. So there you go. That's the forecast, and pretty sure we brought it to you first on the channel. So, cheers. See our video from the 17th if you'd like to see that forecast. And next, Earth's magnetic moment from space. So it's our Geospace Magnetosphere movie. We like to show this so people sort of have an understanding of what's going on in space. Of course, when a proton shows up, it interacts with Earth's magnetic field. So we like to show that's magnetohydrodynamic pressure, the units of which are in nanopascals. So that's sort of what the space environment there looks like around Earth to about 12 Earth diameters. And things are pretty calm at the moment, although expecting things to start to kick up a notch tomorrow sometime after midday universal time, just like we said back on Sunday. So here's our ground magnetic perturbations map, and you can use this one to see the aurora sometimes. So perhaps check that out. You can also check out the geoelectric field map, the empirical data. If you're in North America, it will actually show you induction into the power grid. So that's another sort of real-time data set that you can use for the likelihood of seeing aurora. When you see power grid induction, go outside and look up, especially if you've got clear skies. KP index currently only at 1.67. KP 1.67 is the current state of affairs with geomagnetism. It is geomagnetically calm on planet Earth. Next, some solar wind data. And once again, we had another high-density plasma moment there at ACE. A sputtering, wavy plasma filament there of high density showed up with some areas there over 100 protons per cubic centimeter. But it was fleeting and short-lived, so just a minor CME impact there. Current conditions, quite uninteresting at ACE. Discover also nominal solar wind there, only 2.7 protons per cubic centimeter for the density. Solar wind velocity here, 400 kilometers per second. That is nothing to write home about. GOES magnetometers are next. And let's show the 7-day here as we're seeing a more varied range here showing up just in the past 24 to 36 hours, as we saw higher lows and lower highs there for a couple of days. That's your 7-day measurements by the GOES 16 and GOES 18's magnetometers. Next, we're looking at the top view ecliptic plane field plot. Earth is going to be in a South Pole current sheet, I believe, at the end of this video. But what I believe is irrelevant. It's all about facts. And there you go. Earth is in a South Pole sector. And you can expect that to continue for days. Next is our line of sight field plot. And that's a lot of information over the past 4 days about solar magnetism. Don't understand it? Leave a comment and ask. Next, line of sight coronal hole plot. So we've got South Pole-oriented coronal holes here rotating in, and no real surprise there as Earth is in a South Pole magnetic sector. So let's take a look at coronal holes from the perspective of SDO. I think. So there's a 24-hour video for you. And we are expecting that coronal hole that's rotating into the Earth's strike zone there from the southeast. We are expecting that to be geo-effective. We could have a couple of days, maybe as many as 2 or 3 days of heightened solar wind from that, but don't expect that to show up for about 5 days. 4 to 5 days. So we'll see an increase in the density, a decrease in the density, and then an increase in the solar wind velocity. That's the telltale sign of a coronal hole high-speed stream. Next, we'll move on to sunspots. Those are kind of important. So sunspot number here, again, it's at about 135, 134 according to Rob, the Royal Observatory of Belgium. Here's our flare probability monitor and scoreboard. We do have a high likelihood of large solar flares, especially from sunspot 3615. That's the sunspot to watch for sure. 3615 is the star within the star. Sort of. On the surface of the star, or whatever you'd like to say. Let's take a look at some more data from SDO. So there you go. Mostly stable in terms of the existing sunspot groups. Again, that's what about 135 sunspot looks like. And we do have at least one new sunspot that's risen in the east. So expecting another modest uptick in sunspot number tomorrow, assuming none of those groups rapidly degrade. And what do you got next, you ask? Energetic particles and solar flares. Energetic particles have been flatlined here for today, for the most part. And as far as flares go, pretty mild, only one M-class intensification there. It was an M1.44. And let's take a look at that from the perspective of SDO. We'll show the 94 angstroms wavelength. Yeah, not half bad. And of course, it's little surprise that that flare came from your lower left, sunspot 3615. 3615 is our T-mass, the most active sunspot. Next, we'll move on to a star chart and the solar system forecast. So first, your solar system forecast. There's where things are today. We'll advance this 1 week. There are things on the 26th. It looks like we're right around a full moon on the 26th of March. Next is our astronomy photo of the day, apod.nasa.gov if you want to check it out yourself. And it's a sunset down an east-west road, and that happens on the equinox because that's when the sun goes due east and west, and it crosses the Earth's equator, and more on that a little later in the video. Make sure you stay tuned for our meteorology segment. Next, a star chart from skyandtelescope.org. This is what's going on over our head. Lehigh Valley, Pennsylvania is our location. One of the world's top cycling communities, Lehigh Valley, Pennsylvania. And of course, my shirt that's one of the hardest bike races you can do, folks. As far as mountain bike races go, that's the Curse of Dark Hollow, located in the Michaud State Forest, named for the inventor of the modern bicycle. He invented the bicycle chain, the Frenchman Michaud. Anyway, cycling, bicycles. It's just the most efficient means ever devised to transport humans. No big deal. Anyway, that's your star chart if you want to check out your own. And yeah, the equinox. It's the final countdown. We're counting to springtime. Equinox coming tonight at 11:06 and 28 seconds p.m. Eastern Time. We will not be streaming. I will be sleeping. Anyway, next, CMEs. So there are CMEs from today, mainly that one out of the south, and guess what? It's not earthly directed. So let's keep this section short because it's not really all that exciting, folks. So there's LASCO C2 and C3. And again, there was one CME out of the south. I don't believe it has any earthly directed components. Let's take a look at stereo A as well. That's their location. Stereo B there in blue, stereo A the red dot. Ahead of Earth, orbitally speaking, and seeing a little bit older space weather because it's able to see a little bit beyond Earth, features that have already set from Earth's perspective. And here is stereo A and its difference imagery on the right. So just to show you that that's not earthly directed, or we don't anticipate it being earthly directed based on the available coronagraph data. I guess that's precise enough. And here come some custom coronagraphs. These are some synced up images. And we'll show you where those plasma motions came from. They came from way down at the south polar region. So we've synced together the SDO 304 angstroms along with the LASCO C2 and C3 coronagraphs. And you may see that CME jumping off. Here we've added 193 angstroms, 60-minute running difference imagery. And you should get a great view of that filament eruption. And there's the full disk view. That's probably the best view. And that is the last of our custom SDO videos. So that's SDO 304 angstroms plus 193 running difference of 60 minutes. And it's time to move on to filaments. So filaments, there are filaments in hydrogen alpha from Cerro Tololo. Lots of filaments facing the Earth here at the moment. Let's see, at least half a dozen or so. As you can see, those dark absorption features there, they are reducing the amount of light in hydrogen alpha wavelength there, which is, 62.8 angstroms. The spectra of hydrogen. So here are some spectra of helium, 304 angstroms from the GOES 16 SUVI. So crown prominence there at the northern polar region. Also a huge prominence still trailing sunspot 3599 down there in the southwest. Some activity in the east. And here come bonus features. Satellite charging hazards are first. We ain't got none. It's smooth sailing for satellites. No high energy or low energy electrons building up in or on spacecraft. The GOES electron flux here is now dipped, pretty much as NOAA forecasted it looks like. There's the 1-year graph to contextualize the electron flux. The greater than or equal to 2 mega electron volt electron fluence. Here is our forecast model. Oh, it looks like NOAA did forecast a little bit lower than what we got. I think the next one will be right on. The green boxes are the forecast. The yellow diamonds are the observation. Next we'll show where it's measured, the F layer. So this is the F layer's ionosonde. It's showing you the vibrational frequency of that layer. It's at about 300 kilometers of altitude. Here it is, courtesy of Australian Government Bureau of Meteorology. And shout out to Kimberly for inadvertently showing this data and causing it to get picked up on the channel every day. So that's what's going on in the ionosphere, and so far nothing too exciting, but things are going to drop in frequency sometime after midday tomorrow. So here's the anomalygram. That's anomaly in megahertz from the 30-day median. And lots of blue on there, as it's been geomagnetically calm. Not a lot of solar plasma showing up at the ionosphere. Here's the WAM, the whole atmosphere model. And if you don't know what that is, leave a comment. Our viewers will fill you in if we don't do it ourselves. We read all comments, even if we are unable to respond to them all. We'll close out with the latest. And check it out. 2 new active regions rising here. That one is not a sunspot yet, but the one in the south is, and it's of decent size. So there it is, right behind sunspot 3616, I believe it is. This sunspot here is the T-mass, the most likely place for a large solar flare. And again, expect a minor uptick in sunspot number tomorrow. And let's move to meteorology. So the first thing we're looking at is this massive intensification of the jet stream here. We've got this convergence of the jet stream happening in the North Atlantic, and it's pulling a bunch of warm air way up to Newfoundland and beyond, all the way to Greenland and so forth. So I just figured I would show that. It's a very high-speed jet there, 199 miles per hour. And that's our featured tidbit from today's meteorology segment. Here come the wind patterns of the world. There are the jets of the east. Surface winds shown here. Surface winds of the west, or the central world rather. The jet streams of the Americas, and our surface winds. It looks like a bad day to be sailing Lake Superior, as there are some heavy winds across the lake. Next is our fake NASA spherical projection of the croissant-shaped Earth onto a fake spherical photoshopped template. Yeah, it's a bunch of CGI that people claim is really a picture of the Earth from space. And of course, they do a fantastic job photoshopping the croissant-shaped planet onto that spherical template. Croissant Earth for the win. See the videos for our Redbubble merch, and then perhaps you can stop believing NASA's lies as well. Pardon the sarcasm. I have a dry sense of humor. You might not get the jokes. And if that's so, we apologize. Sarcastically. Right. Now sea surface temperatures. So that's what's going on. And check out the North Atlantic, folks. Oh my God! The Gulf Stream is continuing to warm Ireland and Iceland, just like it has throughout recorded history. Next, the weather.gov map. Weather.gov is where to get your warnings. If your location is lit up on the map, don't get lit up in reality and go visit the website or something and figure out what your weather warnings are, I guess. Weather.gov, the homepage of the National Weather Service. Here comes some forecasts. GFS 72-hour pressure and precipitation is first. That's what's up. Some heavy moisture here making its way from Mexico across the Gulf states in the next 3 days. Some very heavy weather there. Some good surf coming to the Gulf states. Next, accumulated positive snow depth change forecast in inches based on the same GFS 72-hour model. There you go. That's a thing. A little bit of snow here coming, especially to the north central U.S. Some areas they're expecting as much as 6 inches or so. Next is our temperature anomaly forecast in degrees Celsius, and that's our final forecast. It's the final forecast we're putting out during winter. The final forecast. It's temperature anomaly in degrees Celsius, and it's a GFS 72-hour model, and there it is. A picture says 1,000 words. I'd prefer to say less. Next, lightning. That's the past 10 hours. And a string of lightning there across the central Atlantic. And as far as current terrestrial strikes, do we got some? We ain't got none. We do north of Phoenix. There's some thunder rolling in. There you go. West of Lake Pleasant Regional Park. So that's our real-time lightning map from lightningmaps.org. Next time you hear thunder, I highly recommend it. Powered by blitzaltung.org. We'll close out with U.S. Doppler radar for the lower 48. There are the full 50 states, and we've got some lake effect snow here rolling in. We might even see some snow here in Pennsylvania. So there you go. Starting out spring right with some snow. Yeah, you got to have it. And remember, folks, never try to sneak up on a dragon in its own lair. Next is our satellite imagery. Fantastic satellite imagery there. Things are clearing up at the East Coast. And here's our water vapor map. We've got a string of dry air stretching all the way from the New Madrid fault zone up to Newfoundland. We'll close this thing out with a recap of U.S. Doppler radar. That's ground-based systems that measure vertical motion in the air column. You know, ice crystals, water droplets, those things. Satellite imagery based on visible satellite data. What you would see if you were hitching a ride on the GOES satellite. And you had black and white vision. And here is our water vapor satellite. That's infrared. 6.61 micrometers infrared spectra. It shows dry air, it shows moist air, and it'll clear up your Doppler. If your Doppler is unclear, try the water vapor map. You too can forecast your weather, even if it's space weather. Anyway, it's time for me to close out. And thanks for tuning in, by the way, folks. And until tomorrow, may that solar wind be at your back, while I go back to the bunker. Whoa!